Hi, my name is Sumita Puri. I'll begin my presentation on Cisco IPSLA. So let's get started. This is the overview that I'll be including in my presentation. What is the SLAs used, specifically what is Cisco IPSLAs, what do they measure, IPSLA challenges that are faced by the Cisco and what the solution that came up with, then how did it improve the SLAs, how it works, and comparison between the traditional IPSLA with the enhanced one, what was the difference between them, and what did it do in the enhancement to increase the end-to-end performance. Then we'll look at the responder behavior and then the different examples that we'll be dealing with. So let's see. Now the SLAs are between the service providers and the customers, or maybe between the corporate enterprise IT department and end users, are intended to provide the service guarantees and validate the network performance on an ongoing basis. So SLAs should be simple to understand and should improve the mean time to repair. There are different types of SLA in the market given by the different business leaders, like IBM's Maximo SLA managers, then IBM Web Service level agreements, the Cisco IPSLA, Cisco IPM. So I'll be giving my presentation on Cisco IPSLA. That will illustrate the importance of monitoring the end-to-end IP service levels and those at the IP layer in order to provide the true application awareness. So with Cisco IPSLA, Cisco has taken the traditional concept of IP layer 2 IPS to SLAs while advancing the IP infrastructure to become application aware. In order to make real-time network decisions that ensure application quality of service, it is important to measure the end-to-end performance statistics as data traverses the network. So with Cisco iOS IPSLA, service level monitoring is automated. IP service levels can be assured, the network operations can be verified proactively, and network performance can be accurately measured. Active monitoring continuously measures the network performance between the multiple paths in the network, providing the ongoing performance baseline informations. Now let's see what this Cisco IPSLA measures. Cisco IPSLA is a network performance basically measurement that and diagnose that the active users are monitoring, which includes the generation of the different traffic types in continuous, reliable and continuous way and predictable manner. Cisco IPSLAs actively sends data across the network to measure performance between multiple locations or across multiple paths. Now it uses the timestamp information to calculate the RTT, the one-way latency, the jitter, packet loss, and the voice quality and the server response. The issues faced with difficult to deliver differentiated services and monitor service levels. Now in QoS, there are different layers of QoS to which it would require differentiated services. So it faced difficulty to deliver that kind of content. The metrics not strict enough to allow service differentiation. Now in SLAs we can go to milliseconds, but before we can't. We cannot even detect the millisecond delays or problems that you. Many network administrators have not implemented the best practices for measuring IP services and service. When network performance is poorly understood, there is higher chance of network downtime and greater potential for increased network reliability. So if the network administrator can measure how well the network is performing for each service, they can use that information to provide network performance, network operation, and user satisfactions. So effectively measuring and monitoring the IP services in real time, it would contribute to increased profits, effective troubleshooting, and faster deployments of the network applications in order to further business or organization goals. So let's see what Cisco IPSLA have included to overcome these challenges. Here the Cisco iOS IPSLA is embedded within the Cisco software, iOS software, and there is no additional device to deploy, learn, or manage. The dependable tool used to verify these IP services. Cisco IPSLA provide the scalable, cost-effective solution for network performance measurements. This Cisco IPSLA would collect the network performance information real time, the response time, one-way latency, jitter, packet loss, as we looked at before, and the other network statistics. The user can continuously, reliably, and it would predictably measure network performance and proactively monitor the health of the network. It is capable of verifying this, measuring IP service levels and the parameters that needed for the service level agreement. That means it will help you to verify the SLA designed as a baseline. And if design baseline is between 15 to 20 milliseconds, and if anything goes beyond this, it would give the SNMP alert message that would help to troubleshoot the problem that is occurring on the. This Cisco IPSLA can also perform a network assessment for new IP service and verify the per class quality of service levels. It helps you to measure each layer of 7 layers of QoS to which we can measure it, like jitter on voice traffic, latency on voice traffic. For example, like Cisco IPSLA can determine whether the network is ready for voice over IP, and by simulating VoIP codecs and measuring network performance and voice like VoIP quality across the. It would give the proactive notification with the SNMP trap. Thus, if the latency go over the threshold, it sends you the alert and writes it into the syslog server, and from where we can help to get all the data from the syslogs. The network administrator can also use IPSLAs as a troubleshooting tool. Now, the most important feature of the Cisco IPSLA, which differentiated with from other SLAs, is the hop-by-hop performance and the end-to-end performance measurement. It is deployed between the between two. These statistics can be governed by deploying between the two Cisco routers or between a router or server. If the network performance level drops during the operation, like due to congestion, so the network administration can promptly identify the location of the bottleneck and resolve the problem. That's the best feature that Cisco IPSLA have included about the hop-by-hop and the end-to-end performance. Traditional IPSLA versus the enhanced one. So here the layer 2 circuit switch network are basically based on the basis of traditional SLAs. This SLA is like fixed circuits and point-to-point, and there is no way to indicate of the end-to-end user and their applications. So we can basically we can say these traditional SLAs are limited in application. But we know IP networks are currently held accountable for carrying all types of applications that requires networks to internet, like which includes the integrated web service, voice, video. In order to make these all real time, it is really essential to ensure the application quality of service. So it is important to measure the end-to-end. It is really important to measure the end-to-end connectivity and the performance statistics as the data traverses through the network. So this end-to-end measurement is the only way to accurately assess whether the performance statistics are satisfactory enough to support the application. Now let's see how basically this IPSLA works. The IPSLA device sends the packet to the destination using IPSLA timestamps and data to calculate the metrics like jitter, latency, RTT, and voice qualities. So a destination can be configured as a responder that responds with the timestamp information. The responder can send this information about the destination's routers processing delay back to the source Cisco routers. So this delay is removed during the calculation to further improve the accuracy. So even the one-way direction of measurement are also possible with Cisco IPSLAs. So we will see one example later on, like how the timestamps are measured using RTT. So Now the IPSLA can also be configured on per class traffic using by setting the different service code point bits. Also, this notification is also possible, which is a proactive feature with the SNMP trap. Each measurement on this monitors a preset of performance thresholds. So this Cisco IPSL generates SNMP traps, specified values between the 2 points in the network, and a trap sent to the network management system, which is called NMS, we usually is called, can alert the network administrator. And then this administrator can configure Cisco IPSLAs to run the new operation automatically when the threshold is crossed. This feature combined with hop-by-hop measurement capabilities and also enables the immediate real-time problem analysis. So we will behaves when we enable the configurations at the responder end. So when the responder is enabled, this is a source router and this is the target router. Now when the responder is being enabled, it allows the target device to take 2 timestamps when the packet arrives and on the interface at the interrupt level, and again when it leaves. So here we're talking about T2 and T3. So this will eliminate the processing time. This timestamping is made with a granularity with sub-milliseconds. The responder timestamping is very important because all the routers and switches in the industry will prioritize switching traffic destined for other locations over packets destined for its local IP packets, IP address, sorry. So therefore, at times of high network activities, ping test can reveal an inaccurately large response times. So timestamp on the responder allows a Cisco IPSLA test to accurately represent the response time due. So like here we could see there are 4 timestamps which is taken T1, T2, T3 and T4. So to make the calculation for the round trip time. So at the target router with the responder function enabled, timestamp 2 is subtracted from the timestamp 3 to produce the time spent processing the packet. So this is represented by delta. This delta is then subtracted from the overall round trip time, which is T4. And also from the T1 is subtracted from the T4, so on which so we need to note this point that the same principle is applied by the Cisco IPSLA on the source router where the incoming timestamp is also taken at the interrupt level to allow the greater accuracy. So in this way we calculate the round trip time. So at the minute performance. Now let's see one example that will help us to understand better how the alerts are sent according to the configured baseline threshold values. Now here we have configured like the threshold values between 50 millisecond to the 100 millisecond. Now any values that goes beyond that 100 millisecond will do the threshold violation and the alert will be sent through the NMS, and if it goes below the 50 millisecond we probably won't care because we are more care about the value which would increase the delay above 100 milliseconds. So here we can see the alert which is sent if it's went beyond the 100 milliseconds. So this is how the baseline configuration is done when we set the threshold values, and the alerts are sent if the violation has been occurred for that particular base. Now there are different network management system tools that can be used like SolarWinds, Cacti. So I'll give you just example of the Cacti monitoring on which it has been configured to give the details of the jitter errors. So here we can see like from this particular time to this particular time we can see the difference in the jitter values, and here in this one we can see promptly for the hours, not but the among the days, but the in hours what are the different variations in the jitter value that has been occur on the particular network device. And these are just the alerts that are generated on the network devices, so the network administrator could see and could troubleshoot the device with whatever problem has been occurring. So these are the example of alerts that we can see here, where we can see it will give the threshold exceeded for the RTT, threshold below for RTT. So it will now, by looking at this alerts, we can predict that for that particular device they have configured if the two threshold values, if the values go beyond that particular point or it goes below that particular point. Now let's see the sample configuration that we can put on the routers and switches. Like for here, there is a jitter destination for the 1.1.1 for the destination port, and then we can also more than one device we can put in there. The jitter destination IP address 2.2 for the destination port of 8888, and for the here the jitter port for the 3.3.3.3 for the destination port 7777. So this was the presentation that I gave on the IPSLA. So the different sources that I went and came across were like CISCO.com IPSLA, where you can find bunch of information, and most of the information that I was able to speak about I got from the CISCO.com IPSLAs. So you can always go and see the different white papers, and you can research more about IPSLA if you want to know more. Please let me know if you have any questions. That'll be all for the presentation.